Hi everyone, welcome to our beginner series. In this video we're going to be considering how to determine the resistance of a resistor making use of our multimeter. In last tutorial we talked about determining the resistance of a resistor using color coding and number coding. So in this episode we are going to be more practical in the sense that we're going to be making use of our multimeter to determine the resistance of our resistor. Okay, so we have different resistors here. They have different resistance value and they are also of different wattages in the sense that we'll talk about the maximum power dissipated by these resistors. Okay, now we actually have a resistor here. Okay, you can see this very well. We have a resistor here with brown, okay, the first color band brown, black and orange. Okay, we also have another resistor here. We have brown, we have black, we have black here, orange and orange. These two resistors have the same value, but they have different wattages. This will handle small current. The power dissipated by this resistor is very low compared to this. Okay, so this will handle a larger amount of current. Okay, so let's go into what we have today. Now you have your multimeter with you. If you've not watched our tutorial on how to make use of multimeter, please do well to watch it. I have included the link to that video on this on the description of this tutorials. Okay, so we have our multimeter here. Remember to connect your black probe to where you have the common and your red probe to where you have your resistance symbol. We have V. Take note, we have V here. All right, we have V and we have the resistance symbol, which is ohms here. All right, so first and foremost, let us pick any resistor at random and let's use that as our case study. Okay, let's go with this resistor we've worked with before. All right, so let's turn your knob to where you have resistance. Okay, so this is where we have the resistance symbol. Okay, so here our multimeter is on 200 ohms. If you can see very well, we have our multimeter on the 200 ohms range. Now when you place your, remember in previous tutorials I talked about resistors not being polarized, so any direction you actually fix your probe, the probe of your multimeter, you're going to get readings. Okay, because resistors are not polarized. All right, so okay, so when you place the probe of your multimeter on the terminals of your resistor, if at a particular range and you're not getting any reading on your multimeter, it therefore means that either you are out of range or below range. Okay, so we place our probe now. Place our probe. We're not getting any reading on our multimeter, so let's go to the next. Let's turn to the next range. Okay, let's try this. We're not getting anything. Let's proceed further to the next range. Let's see what happens. Oh, that is it. We have a reading now, and in this case we are having 9.66. Why 9.66? Because if you actually do your calculation with your resistor color coding, okay, you do your calculation with your resistor color coding. This is brown, this is black, this is orange. It's going to actually give you 10 kilo ohms, while we're having 9.66. okay, now during manufacturing a lot of things actually happen that can either decrease or increase the resistance of a particular resistor beyond its stated value. All right, so that is why we have tolerance. The last band here, which is gold, is our percentage tolerance. So this resistor value is actually 9.66 kilo ohms. Okay, let's pick another resistor. Let's, for another example, okay, this, let's connect our probe. Oh, we're not getting any reading on the screen. Why? Let's go to the next range. Let's see what happens. Okay, so we have 9.83 kilo ohms this time. 9.83 kilo ohms. Remember, we're in the range of 200 kilo ohms. We are above 220 kilo ohms now. So 9.83 kilo ohms. Ideally, all right, if you go to the resistor color coding table, you will with this color you will see, you will be able to calculate. If you calculate with brown, black and yellow, you will get a value of about 100 kilo ohms. But how come we are having 98.3 kilo ohms here? Remember tolerance. All right, so We also have another resistor here. This is a 5-watt resistor. This resistor can handle a higher amount of current. This is a 5-watt resistor, 5 watt, 4.7 ohms. All right, 5 watt, 4.7 ohms. This does not actually require a color band or color coding table. The resistance is actually stated on it. Now, when you pick up a resistor, okay, and you see any physical damage on the resistor, okay, you see any physical damage like something showing that it is burnt, there is every possibility that that resistor is actually damaged. Okay, it's not fit for use. Okay, and then when you pick up a resistor, for example, after trying out all the ranges on your multimeter and you are not getting any reading, okay, and you are very sure that your multimeter is working and you're not getting any reading, it means that that resistor is bad. Okay, so take note of that. So I hope you are actually enjoying our tutorials. Please do well to like, share and comment, and as well share with your friends